Part 2 of misleading graphs has just different types of graphs and possibly different types of questions that they could ask. So let's take a look at the first one here. Which graph could be misleading and why? So it's the same exact question, but just a different type of graph. So let's take a look at them. And again, as I talked about in part 1, the idea I always look at to see if a graph's misleading is along the axes. So I look for something, a symbol that shows that the intervals are different. And this symbol right here shows that they have broken the x or the y-axis, the vertical axis here. So they broke this y-axis, and the reason they did it is because they wanted the numbers to be closer together. Where over here, you see they didn't do that. They have consistent intervals. So here, the intervals were not the same. Well, at least they were the same, but not initially. They went from 0 to 9, and then they had the intervals going by 1s. Here, they have the same distance. They're going by 5s, 5, 10, 15. And the reason why this one appears to be is that because of this broken symbol, but what makes it seem so much different is that when you look at it, it looks as though the favorite pet by far is the dog. And it is the favorite pet, but is it so much more than any other pet that they have here, the cat or the fish? Well, if you look at the other graph, see the cat and the fish are about the same, but they're definitely closer to the amount of votes that the dog ended up getting. So you see how the cat is up to, well, about the dog's neck or so, and the fish is up to, well, about the dog's neck as well. Over here, the cat is only up to the back, where here the fish is up to the lower back of the dog. So you can definitely tell that it definitely looks as though the dog has many more votes than the fish or the cat. And so that's what you would explain here. So we'd say the graph A is misleading, and the reason, because we have to state why, is that we'll say the broken interval makes it appear the dog, or we'll say dogs are twice as popular. So they're the pet that most people would want. In looking at graph A, you just assume that without having to look at the numbers. But when you look at the numbers, you see again the numbers are going to be the same. See, they show that the cat is just over 10. Here, the cat definitely over 10, right at about 11. So the numbers are consistent. So if you looked at the numbers, you'd be able to figure out the same information you would here. The difference is what the graph, the visual aspect of it, looks like. And that's what people kind of pull towards when they're looking at these graphs, is the visual aspect. And sometimes they don't even go to the numbers and actually figure out what those values are. And so that's why that one is misleading, is because, again, that broken axis. Let's take a look at the next one here. Explain why this graph, the one down below, could be misleading, then redraw it so it's not misleading. So let's take a look at why. Well, looking at it, looking at the intervals, again, we always look at these intervals to see if they're the same. What's different about this? Well, 0 to 10 is a huge difference here. These are not the same, so we have unequal intervals. So the vertical axis has unequal intervals. And so that's what we need to change. And so when we draw our new one, what we want to do is be able to use the same numbers they have here, but we're going to end up having to input some values in between here. So what we can do is we can even go by, well, actually, I'd probably go by different numbers instead of by tens, because looking at this, we have a few that are below 10. So maybe let's go by 5s. So we'll call 0 here. Again, this is the population, so I'll just write population, POP for population, in the millions. And down below, we still have the states. And so we'll have the same states. I'll get those in just a minute. I'm just going to make a mark here for 5. and then we'll go to 10, and then maybe 15, and 20. So notice that my intervals I'm trying to make the same. And so here's 25, and we'll make right about here 30. So those are my intervals, and then from there I'll go ahead and draw them. So I'll start with Massachusetts, MA, and so we go ahead and draw it to where we think it is. Now it looks as though it's right in between 0 and 10, maybe a little bit higher. So I'll go ahead and draw it just a little above the 5, or right at the 5 is probably okay as well. And then from there we'll move on to the next one. So I look at the next one, North Carolina, and C. And so this one appears to be just below the 10, maybe halfway in between 10 and 5. So maybe about 7.5. So I'm just going a little above, just right in between those two, right in between the 10 and the 5. And there's North Carolina, Pennsylvania. We're going up, looks like just a little over 10. So if I go across here, I see it's just a little below halfway, so maybe about 13 or so. Actually, more like 12, and so I'll go just a little below that. 15, or a little above 10. And then I go ahead to Texas, TX for Texas, and that is really high. It's up close to 25 million, so I'm going to go right at the 25 there. And then I go ahead and hit Virginia. So Virginia is a little under what North Carolina is. So VA, and go ahead and draw that one in. And so this one makes it appear that when we looked at this first one here, number 2, the intervals of the axis were unequal. And so it kind of appeared to me as though they all are the same. But when you look at this graph here, when we draw it out, it appears that Texas is definitely a lot bigger than the others, and the others are pretty close to each other. And so Texas is kind of an anomaly compared to the other states that we were looking at, probably because it's so big. And so there it is. There's our redrawn one. So again, the key on these, when we look for misleading information, look at the axes. Make sure the intervals, we'll say axes, the axis intervals are unequal, or you have a broken axis. So that's what you're looking for when we're dealing with misleading information. So misleading is when the axis intervals are unequal, like they were over here, number 2, or when we have a broken axis, like we did here on number 1. So those are the different things you'll be looking for on tonight's homework. Good luck.